Way back in March 2011, Japan experienced a large earthquake, followed by a 46-foot-tall tsunami that crashed into coastal communities. Of particular concern was the Fukushima Daiichi nuclear power plant in Okuma, which was suffering technical issues in the wake of the natural disaster. The earthquake was detected by sensors built into the power plant, and the active reactors were automatically shut down, stopping all fission activity. This sudden lack of energy production, complicated by further technical issues in the grid, led to the water circulating pumps shutting down. Fortunately, there were backup generators that started, and the circulating pumps were kept going for a while longer. But then, the tsunami hit, drowning a seawall and partially flooding multiple reactors. This knocked out the emergency generators, which stopped the water circulating machinery. Now this was really bad, because these water circulators are needed to cool down the fissile material and remove heat. When they stopped, heat started building up, leading to 3 meltdowns, 3 hydrogen explosions, and the release of huge amounts of radioactive cesium isotopes into the air and ocean. Over 150,000 people were evacuated, and now, more than 10 years later, many people have moved back, but there remains a Fukushima exclusion zone, where people cannot live due to the radiation. This brings us to today's news. Researchers from the University of Georgia have conducted a study and found that the radiation in this Fukushima exclusion zone can be effectively measured using snakes. Yeah, like the long, skinny serpent reptile with no legs. Specifically, they used 2 species known as rat snakes, the Elaphe chlamycophora and the Elaphe quadrivirgata. They used these 2 snake species because apparently they don't move very much. They travel really short total distances day to day, and they don't roam too far from a limited territory. The researchers calculated that the average rat snake moved about 65 meters, or 213 feet, per day. The research team spent a month in the Abukuma highlands, about 15 miles northwest of the power plant, where they found over 1,700 sites with rat snakes. In a previous study conducted by the same researchers, they identified radioactive cesium particles in the soil, which correlated to radioactive cesium particles found in the snake's tissues. In this study, they attached tracking devices to the snakes to measure their movement patterns, and they found that the snakes were generally concentrated around the edges of forests. They were more comfortable deeper in deciduous forests, and they would hang out in abandoned buildings and underground structures. They speculate that in the colder winter months, the snakes would spend more time underground and would thus get more radiation exposure. Dr. James Beasley, senior advisor on the research effort, said, quote, "Snakes are good indicators of environmental contamination because they spend a lot of time in and on soil. They have small home ranges and are major predators in most ecosystems, and they're often relatively long-lived species." Unquote. So, by being in contact with the soil a lot in a limited area where they eat the local wildlife, they're bound to accumulate any local environmental contaminants, like cesium radionuclides. We can capture these animals and sample their tissues to detect radionuclides and attempt to measure the radioactivity of certain regions. But more research is going to be needed before this can be turned into a practical, useful, in-the-field technology. For example, we still have to figure out the relationship between the magnitude or rate of exposure and the radionuclide concentration in the snake's tissues. This data will be really useful if we can establish a mathematical relationship, although this might be tricky because Dr. Beasley mentioned that the radionuclide levels can vary from snake to snake, based on the particular idiosyncrasies of their habitat and the way they interact with it. So there's still a fair bit of work to be done, but if we can smooth out the wrinkles, these snakes may become a useful biotechnology that can help protect humans from dangerous regions that might be contaminated with that most nightmarish of materials: radioactive materials.